Good morning. My name is Sergio Garcia, PhD. My PhD is actually in finance, not technically in mathematics, but that's why you have me as a business professor. I'm a big stats guy. I'm a big stats guy, and that's why we're going to work together. So today we're going to work on notation. There's a couple of things. Most of this you guys might know, but we're going to work on anyway. And so the first thing I'd like to work on, let's erase all of this. The first thing I'm going to work on is talking about what happens when we look at a data set. So sometimes we have an X, not sometimes, we often have an X or any other variable. It doesn't matter. This is just a variable. It's any variable. It doesn't matter which one you have. Matter of fact, I need a little space here in a minute. And this variable, you can measure it as weight or inches or pounds or whatever. Let's make some data here just so that we have something to play with, whatever it is. And what we're going to do is create this variable and give it a certain number of counts. And so we often will use the letter I or J, sometimes I, J, K, very common uses or common letters for counting variables. And so we're going to say this is the first variable, this is the second, nope, not variable. This is the first observation, this is the second observation, this is the third observation, this is the fourth observation. I is really just a count of observations. We often will also use the letter N, where the first N is number 1 and the second N is number 2. Let me put N over here as well. N3, N4. N is often an observation. I is often the observation that we are interested in. So I could turn around and say, hey, what is X sub I, where I is equal to 4? Then I say I, so I'll come over here to I and I'm like, this is number 1, this is number 2, this is number 3, this is number 4. What is the observation of X when I is 4? It is X sub I is equal to 7. And that's the actual observation for X sub I. But let's back that up. Let me make a much bigger eraser here. Not exactly what I'm looking for, but that'll work. All right, so that's very common, and we have to remember that we're addressing certain observations. Specifically, one of our favorites, very common problems is going to be the summation of X sub I over capital N. Well, a couple of things happen here. When I say capital N, what we mean here is the total count, or just the count. And just like we have a small n here, this is n 1, 2, 3, 4, the n is also going to be the last n. Okay, why the last n? Because the last n also represents the total count. What does that mean? It means there are 4 total observations. 1, 2, 3, 4 total observations. The capital N just denotes that we are grabbing the last n, or the total number of observations, and there we are. All right, so this is going to equal to 4. I can delete all of this. So this is going to equal to 4. But then X sub I summation, what does that mean? Well, summation means to add up, obviously, right? No big deal there. X is a reference to this X, is a reference to this X, and I is a reference to, you know what, let me do that in a different color. We'll get a little crazy here. And this I is a reference to this I. So what happens here? We are going to add up all of the X's one I at a time. So we're going to say here, this is equal to, what's the first I? The first I is 1, so take the 4. This is 4 plus, what's the next I is 2, take the 3. 4 plus 3 plus 8 plus 7. And since this is divided, we're going to divide one by the other. Let me make this yellow since we're all in yellow. Okay, so what are we really doing here? Well, this is the average. Let me scroll this up so we have some space here. Scroll, feel free to scroll. So here's the average. We're doing the summation of x sub I, which is equal to 4 plus 3 plus 8 plus 7, is equal to what? 4 and 3 is 7, and 8 is 15, and 7 is 22, divided by n, or the total number of observations, which is 4. 22 divided by 4 is equal to 5.5. This is the same thing as the summation of, which is the same thing as the average. What's important here is that you recognize the notation. Summation means to add up. When I have x sub I, I'm talking about the variable x denoted by the ith observation. Very important observation. Right, so you know which one I'm talking about. When I put the summation in front of the x, it means add up all of the variables I at a time or one at a time. Okay. Next, you're often going to see x bar. This means the average observation. Not to be confused with mu, which means the average of the population. Now, this is critical. The critical distinction. X bar is not the same as mu. Here, we're talking about all the observations that we're able to gather, and mu is the population. How is that different? Well, the observation, imagine that we have all the caterpillars in the world. All the caterpillars. Can we count all the caterpillars in the world? No, they're all over the place, right? But I want to know what they're like, so I take this sample. So I take a sample of all the caterpillars. X bar refers to the average of the sample, where mu refers to the average of all the caterpillars. What we're going to do later in the semester is we're going to look at the sample and we're going to project it out here. Okay, and that's kind of the big picture of what we do in statistics. We don't always have access to every single box of tools. We don't have access to every paperclip. We don't have access to every human. We don't have access to whatever, every cancer survivor. But we take a sample of them and we project them from here out to here, and we say, hey, look, maybe you should take vitamins every day, or maybe you should exercise. Well, how do you know? Have you tested every human? No, I haven't, but I've tested enough humans on exercise that we can do one or the other. To that end, when I say X bar, or more to the point, any variable, right? Y bar, variable bar, age with a bar on top. The bar on top means the average, not to be confused with mu, which is specifically the average of the population. Okay? As you know, any number up here is called an exponent, right? So that tells you how much to address it by. This is a mathematical number. A number in the bottom is a placeholder. We've already talked about that. A place or a number or an identifier. Okay, these are instructions at the bottom. You're identifying an individual, or you're taking instructions from I to J or whatever. Sometimes you'll see something kind of weird, not in statistics per se. Well, in statistics, but you say X is equal to I, right? That means start at I. You might actually see X equal to 1 all the way to 5. This means I have, sorry, that's not an X at all, it's an I. X is 1, 2, 4, 4, 8, and I, or 9, and it keeps going, and I is 1, 2, 3, 4, 5, 6. That means what this is telling you is start at the number 1 and continue until you get to number 5, add this one, and 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 stop here. Do not add the numbers, do not add the number 6 observation. So you're going to add these guys and leave this one out. Sum these and leave that one out. Hopefully that makes sense. Here's an equation you're going to see x sub I minus x bar squared over n. And this encapsulates a lot of what we're doing here, right? What we want to do is, in this case, we're going to do pretty please my dear Aunt Sally, and there's actually more verifications of that. First, we do powers in parentheses, then we do multiplication and division, then we do addition and subtraction. No surprise there. Here, the order of operations is important. So what do we do first? First, we do what's inside the parentheses, then we do the square, then we do the summation, then finally we do the division. So make sure you understand powers of operation or order of operations. They're going to come in handy later. Let's talk again. I know we've covered it just now, but let's talk again. I, N, J, K are often going to be used as identifiers. Don't be surprised. There, summation is to add, right? Those of you who have taken calculus, you know that this is integration. We're not going to do that here. You might see it in some notes along the way, but don't sweat it. Little n is equal to identifier or the numberth, that's not a real word, numberth observation, where capital N is equal to the total count of observations. You'll see that a lot. In statistics, you'll often see P. P is a proportion. Proportion. So you'll see that from time to time. Almost always, not always, but almost always. In this class, we'll use that as a proportion. Sigma is equal to a standard deviation. Always, always, always. S is also equal to standard deviation, except this one is for the population. Sorry, backwards. This one is for a sample. Think of the S as the S for sample, and the sigma is a sigma for the population. Okay, you'll see those population, that's no T. So you'll see that one over and over again. Sigma, 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 and you'll hear me lecture in sigma. When I say sigma, it's a critical concept. Sigma, you'll always see sigma or some variation thereof. When we talk about variance, this is equal to standard deviation. Standard deviation. Variance is equal to sigma squared, right? Sigma squared, not that I have to spell it out. So clearly the square root of variance is equal to the square root of sigma squared is equal to single sigma is equal to standard deviation. You'll see that over and over and over and over again. All right, so don't be surprised by that one. A single sigma is equal to standard deviation. I'm saying it again and again and again. And sigma squared is equal to variance. Keep those in mind. Keep those in mind. Keep those in mind. I'm trying to go through my notes here, see if I've forgotten everything. Yes. X hat. You'll often not see X hat. You'll often see Y hat. The hat above any variable means resolved, or this is the answer. Why is that important? Well, sometimes you'll calculate y. Y is equal to mx plus b, and you'll take an x and you'll plug it in, and you'll get you'll get an answer. And in this case, the y is equal to whatever, 4, right? This technically is y hat. Okay, the y hat, the answer is equal to 4. And so you might have a secondary equation where z is equal to x plus y hat. Well, what you would do with the secondary equation, since y is 4, is you would take the 4 and you would plug it in here. It's important to know that when I say y hat, I mean resolved or answered. Okay, you'll see that from time to time. You'll see that from time to time. What else? Down the road, you'll see some very specific things like MST. When we get to it, that'll be like mean square treatments. Don't memorize that, but know that we'll sometimes have specially denoted stuff, so you'll want to be paying attention. Those are the big ones. So if you see something you don't know or you see something you don't like, note that math is a language and it has its own specific notes. One more time, the big ones. X bar means average from the sample. Mu equals average of the population. Sigma is equal to standard deviation of the population. S is equal to the average, the standard deviation of the sample. We'll see those over and over and over again.